at this point, we know a lot about the ideal methods for conducting experimental research in the lab, research about causal claims, the three causal criteria, temporal precedence, covariance, and internal validity. And when we move into this conversation about quasi-experimental designs, these are situations in which we want to know about cause and effect relationships, but we can't run a controlled lab study where everything is perfectly and tightly controlled. And usually people introduce this topic by saying we can't or don't have access to perfect lab studies, but sometimes you don't want to run a lab study. You want to look at natural variation that's occurring in the real world and do your best to approximate these group comparisons that we make when we have random assignment to groups. For example, in a between subjects experiment, we can look at sort of naturally occurring variation. So I think Tamara used an example in the first day of class about natural variation in water quality. These are quasi-experimental designs, and there are a few different types. So quasi-experiments can be between or within subjects, just like experiments. The most common type of between subjects quasi-design is called the non-equivalent control group. So we'll go through a couple examples of that. And there's also within subjects designs where really the idea is we're trying to mimic what we would do in an experiment without actually bringing people into the lab and running a true experiment is the term. So we're going to talk about 4 examples of quasi-experimental designs. And what I like about all 4 of these is they take a situation that occurs in the natural world and they harness variation that exists as their version of an experimental manipulation. And so we're going to go through these pretty quickly, but feel free to stop me. I'm happy to stop if anyone wants to talk out the details of another. So Head Start was an educational program that was popular back in the 50s and 60s. Researchers wanted to understand the effects of being enrolled in this Head Start program on children's educational outcomes. So this was a program that children had to qualify for if they were in a low-income household. This is sort of extra tutoring and environmental resources directed toward children. And we might want to ask the question as researchers, did children who were a part of this Head Start study have better educational achievement afterwards than students who were not a part of the study? So was Head Start effective? Did it help? Did all this government money that we poured into doing this special program have effects that we wanted, the intended outcomes? And so one way to do this is by taking a quasi-experimental approach and finding a non-equivalent control group that we can use to compare to students who had been in Head Start. And by finding a group of students who are similar enough, so matched for demographic factors, this is really the key of a good quasi-experimental analysis, because we can't randomly assign, we're not randomly assigning some kids to be enrolled in Head Start and some not. You know, Head Start was a federal level program. Some elementary school students qualified for it and some didn't. But what we want to do is find a group of students who are similar in every other way that we can possibly control for, in age, in pre-test scores, in ability before they were enrolled in the program. And then we look at our dependent variable, in this case is Stanford Achievement Test Scores. We look at test scores after the program, and we try to see the effects of our treatment or manipulation, which was this federal level program. So sort of taking the framework of an experimental design and imposing it on a real world variation or difference in conditions. We have two between groups here, two independent groups. It's sort of mimicking that independent group's design. And so that's one road toward understanding the effects of a program on our intended outcomes. So the graph shown here, it actually looks like students who were in Head Start had lower test scores than matched students who were not in Head Start. And there have been studies that have shown Head Start resulted in some positive outcomes. There have been sort of a mix in what I've seen on researchers' understanding of whether Head Start was effective, but hopefully that gives us a look at that non-equivalent control groups design. Here's a quasi-experimental design that mimics the within groups framework that we learned about last week. So we're all familiar with the idea of parole decisions, and people generally agree that legal decisions such as granting parole should be made as objectively as possible. So judges or parole officers hold hearings where inmates come up and make their case for being let off on parole. And these judges might hear 12 cases over the course of a day. And they might start at 9 a.m. and they might hear a few cases before lunch and they hear some after lunch. And what we want when designing the system is for those decisions to be as reasonable as possible. It's like when I'm grading your papers, for example, if I pull up, if I sit down to start grading and I pull up someone's paper first, I don't want to be more harsh on the first paper that I grade than I am 20 papers later, just because, you know, I had the juice to be harsh early on and then I sort of got tired and lazy later on. We don't want that. We want objective criteria maintained throughout. And that was the idea behind this study. So over time, we're looking at the proportion of favorable decisions made. That's the dependent variable on the y-axis. And on the x-axis, we have cases throughout the day. And so these are data from a real study that was conducted with persons who were in an Israeli prison. And they looked at, so this is called, the type of design we're looking at here is called an interrupted time series design. So over time, the same judges, we can track their parole decisions and see, if you take a look at the figure in the upper right-hand corner, we see that they start out favorable, they over time become more harsh, and then something happens at this moment in time, this first vertical line, that is the first lunch break of the day. When judges come back from their first lunch break, they're refreshed and feeling good, and they start favorable again. And they gradually get harsher until their afternoon break, and then they're refreshed. And so we're seeing, we're learning from this quasi-experimental study that the way parole decisions are made might not be perfectly objective or just, because the judges and parole officers are just people too, and they're subject to the biases of, you know, how their body's feeling when they're making that decision. And so this is a really interesting real world example, and it's within subjects because we're looking at the same judges over time. And so we might be pooling data from, you know, a group of 50 judges and looking at how their favorability of their parole decisions varies over the course of their day. And we might pool all that data. There's no between subjects difference. There's no treatment. You know, we could have a mixed design where we look at a between subjects variable like gender of the prisoner or gender of the parole officer, and also track decisions over time. That would be a more complex experimental design with two independent variables, one within subjects, time, and one between subjects. But here we can see what the interrupted time series design looks like. It tries to mimic the repeated measures within subjects design we learned about last week. And it does so in this real world context where we can learn something interesting about how parole decisions are made. It's not a true experiment because the independent variable was not manipulated, but instead it looks at this naturally occurring independent variable of time of day, which is inherent in the process of granting parole decisions. This is the way they're done. A judge might hear 12 of them over the course of the day. So hopefully we are getting a flavor of a taste of these different flavors of quasi-designs. I'll show another between subjects example. This is another non-equivalent control group. So imagine that people are coming into a surgery clinic and they want to have a plastic surgery done. And we want to ask this question, what are the effects on self-esteem for people who get a certain type of cosmetic surgery done? Well, we can, the key here is finding that really good non-equivalent control group. So it'll never be perfectly, we could never randomly assign some people to get cosmetic surgery and some people to not. That wouldn't be ethical. But what we can do is come up with a clever way of tracking those people who come into the clinic, have the first meeting, register for plastic surgery, but then pull out. They decide not to carry forward with the plastic surgery, and we could track their self-esteem over time and compare it to those who came in for an initial meeting and did have the plastic surgery. We'll probably hold constant the type of plastic surgery, say it was a nose job or something in this case. And by comparing these two groups, we don't have a perfect experimental design, but this is our best guess at what it would look like in the absence, the same type of people who are interested in a nose job, but without actually getting that surgery done. So we're trying to isolate the effects of getting the surgery. So it's the cause and effect relationship here is between getting plastic surgery done and self-esteem. We wouldn't want to compare people who go into a clinic for a nose job and got plastic surgery done to any old group of a random sample of the population, because there'd probably be a lot of differences there. We want to find the best comparison group we can. And that's why in this example, we're going to harness people who came in for that initial visit but didn't carry forward. So non-equivalent comparison or control group, but we're always striving to be as equivalent as possible, because in true experiments, random assignment is sort of our magic wand at getting these two different groups to be equivalent in all ways, except for the treatment that we manipulate. So there's another example of a non-equivalent control group. I want to show one more example. This one I really like because it was done here at the University of Oregon by a graduate student who was in the economics department at the time. Her name was Dolkan, and I pulled this from an Around the O email blast back in 2017. So I believe this graduate student was preparing to become a new mother at the time. So she was very attuned to alcohol warning labels in liquor stores. You can see in the image here, there's this pregnancy and alcohol do not mix warning label that Oregon institutes, but not all states have the same laws related to alcohol warning labels. It's something, it's like for people who have seen, on cigarette boxes, they try to put pictures of what it'll do to your lungs. It's in this family of regulations designed to, ramp up the perceived costs of engaging in this risky activity, designed to deter people from engaging in this activity that the government, knows is bad for our health and doesn't want us to do. But some states have these warning labels and some states don't. And so we might want to ask the question as researchers, do these warning labels have an effect on the consumption of alcohol in pregnant women? And one way we can look at this is by looking at birth outcomes, records of fetal alcohol syndrome, um, and post, birth weight and preterm birth are two other outcomes that are commonly associated with drinking during pregnancy. And so we can track those outcomes and see, do states that have alcohol warning labels have lower instances of preterm birth and healthier birth rates? And if so, we could say this is an effective policy. This simple label does help some people stay away from alcohol when pregnant. And I believe that's what she found. She found that laws with alcohol warning signs, states that have alcohol warning signs in liquor stores did see healthier birth weights and fewer preterm births than states that do not have these warning labels. It was a nice comparison because I think at the time, there were about 23 states that required these alcohol warning signs. So, if there were only one or two states, that wouldn't be a great comparison. We'd be comparing 2 states to 48, but it was a nice split. It was a nice split into, 2 between subjects groups, you could say. But instead of dealing with individual study participants, here we're dealing with states. And instead of, experimentally manipulating, we're dealing with the policies that they've put in place. So we're using the law of the land as our experimental manipulation, so to speak. And so that's why I love examples like this. And we can probably all think of some other ones, especially in a complex nation like the United States, where different states have different laws. And here are a couple that I thought of, but if anyone else is thinking of any now, I'd love to hear